Hey everybody. All right, this is lesson 22 in module 4. And for this lesson, it's a pretty big one and it kind of has an important concept just about thinking about math. So the objective is to compare the size of the product to the size of the factors. Remember that it's factor times factor equals product. So what are you multiplying to get this answer? So in the book, we start out with thinking about fractions, okay? If I have 4/4, 4/4 is equal to 1. I can multiply 1 by 12 and get 12. If I have a fraction like 3/4, this is less than 1. So if I am multiplying 12 inches by a number that's less than 1, what I'm saying is I want less than what I had before. My expected answer should be less than 12, which it is. Okay, so if I have 1 times 12, I get 12. If I have less than 1 times 12, I get less than 12. But an improper fraction, like 5/4, is greater than 1. 4/4 is 1, so any number on top that is greater than 4 would cause this fraction to have a value that's greater than 1. And when I multiply a value greater than 1 times the other factor, my answer will be greater than what I started with. So today's lesson is all about thinking about the reasonableness of your answers, okay? More practice problems. 4/4 is 1. 3 out of 4 is less than the whole, so then you end up with less than 1. A lot of comparing today. 5/4 is greater than 1. Really understanding that. This is going to be the scale factor. You are going to use scale factor today in your, you have to like put a box around something and put a circle around the other thing. And so you have to know what the scale factor is. The scale factor is how you are changing your original factor, okay? The other one, okay? This is what I have first. This is my factor. And then I'm going to scale it up or down. And so scaling it up, that's making it bigger. Scaling it down, making it smaller. Do you ever cook with your family in the kitchen? You have to double a recipe. Okay, you're scaling it up. If you want, I only want to make half of this because half the kids are gone, then I'm going to scale it down. Scaling is changing the overall size of something. Okay, so anyway, more samples of that. And then this is kind of connecting to what we're doing in the book. So you're going to rewrite as a multiplication sentence and circle the scale factor and then box the meters. So if a problem said 1/3 as long as 6 meters, I have the 6 meters, but I'm going to change it so that I only have an amount that is 1/3 as long as what I have. So that would give you 2 because 1/3 of 6 is 2. So my expected answer, if I'm taking a fraction of this whole, I should have a small number. Okay, flip that around. 6 times as long as 1/3, this is what I have. That's why it's going here. Remember, what you have goes second in your setting up of the fraction. I know it doesn't always matter like when you get to the end because the commutative property says when you multiply you get the same answer. You will, but sometimes you're going to have to identify like what thing goes where, and that's what you have to do today. So here are some tape diagrams, but the lesson is a little bit long, so I want to kind of jump in there. Anyway, more practice down here at the bottom, and let's get into the book. Again, if you don't get all the lessons, the notes in class, then you can copy from the video. This is page 255. And it says, solve for the unknown. Rewrite each phrase as a multiplication sentence. Circle the scaling factor, whether we're going to size it up or down, and put a box around the number of meters. So half as long as 8 meters. So what they're saying is I need to figure out the number sentence for this statement, half as long as 8 meters equals how many meters? This is what I have Okay, so I'm going to put a box around the number of meters. I have 8 meters. My scale factor is half. I'm going to take half of that. And so half of 8 is 4. You can do this, or you can just do 8 halves, but you're going to get 4 meters. Okay, so that's what they want you to do. They want you to show that you know what goes where. In this one, it's 8 times as long as half meter. So 8 times as long as half meter equals how many meters? Well, this time I have half a meter, but my scale factor is 8 times that. So you want to multiply. Now notice that 8 times 1, I can do it this way for those of you who want to see it this way. I'm still going to end up with 4 meters. Flip-flop, 1/2 times 8, 8 times a half. Okay, the commutative property is really evident right here. I'm going to end up with the same answer. However, I didn't have the same number of meters. So sometimes if a word problem asks you, that's what it's going to be for. They're saying, well, how many meters did you start with? That would be a question you could see on a test. Okay. Draw a tape diagram to model each situation in problem 1. Okay, so each of these situations gets a tape diagram that goes with it. And describe what happened to the number of meters when it was multiplied by the scaling factor. So for this one, I have 8 meters, but I want half of it. So I'm going to draw a tape diagram. And I'm going to call the whole 8. And we're going to divide it in half. And this is what we're looking for. That would be the question mark. Okay? Now, here we've solved and we got 4. Okay? Now let's do the other one and then we'll describe after we're done. This one we have a half meter. So what I want to do is I really just want to show you that it's 1/2 8 times. So I'm going to make 4 and then I'm going to do 8. And then I'm going to show you that this is 1/2 meter 8 times. Okay? And so when you get that, the total on the top, look at the difference. Okay, I'm still getting 4 for my answer. I'm still getting 4 for my answer. They just look different, okay, because this is 1/2 repeated 8 times, and this is 8 and then half of that, okay? So different tape diagrams. Now, if we describe, then I would say the scale factor here is less than 1. So the meters decreased. Okay, but here the scale factor, okay, was 8. Remember, we had to circle it. The scale factor is greater than 1. So the meters increased. Okay, so we're thinking about what we start with and how we change it and what we end up with and does it make sense. Now we're going to look at some fractions that they've kind of started for us, but we have to fill in the blank with the numerator or denominator to make the number sentence true. Okay, so we're going to make it true. Now these aren't equal signs, it's comparison, so it's greater than or less than. So if I have 3/4 on this side and I am comparing it to 3/4 on this side, but I need to have a greater value over here on the left, then you get to choose a fraction to write in all 3 blanks, the same fraction, okay, that would make all 3 number sentences true. So right here what I'm thinking is I need an improper fraction, okay? I need something that is going to make 3/4 get bigger because my greater than sign is facing this way. What about this one? 2 times a number has to give me something greater than 2. Well, if I had an improper fraction, that would work there, okay? Now this one has an improper fraction already, and I need to multiply it by something, and get something greater than 7/5. So you can put in a fraction of your choosing that would work all across, okay? And so usually in class we like throw different things out and we work them all out, but for time, I'm just going to put in this, let's say 5/2, and that would be an improper fraction, would give me greater than 1, and greater than 1, which would make this work out, and greater than 1, which would make that all work out nice. And explain how I know, because multiplying by an improper fraction is multiplying by a number greater than 1. Okay, so it makes the product larger. Okay, larger. Sorry, it's kind of sloppy. Just another day. Just another day in my classroom. Okay, now how do I get 3/4 to become smaller? How do I get 2 to become smaller? How do I get 7/5 to become smaller? Basically, what you just need is any fraction that is a fraction of a number, not an improper fraction. Okay, so improper means that 2 goes into 5 2 whole times with 1 left over. This is really a mixed number. It's a whole number and more. But if you use a small fraction, just a piece of something like a half or a fourth or something, then you're taking a piece of this. Okay, so I could use a half, I could use a fourth. A fourth of 2 is going to give me something less than 2. A fourth of 7/5 will give me less than 7/5. So you can use any fraction you want, and again, less than 1. So you try a fourth for all of them. And sorry, that one's almost illegible. 1/4. Work on those numbers. Make sure you can see them. Any fraction. You guys can have others. Again, any improper and any proper. And so why does that work out? Because multiplying, you have to write this. Multiplying by a proper fraction less than 1 will give a smaller product. Okay, and so what you want is a smaller product than what you started with, whatever you started with. Okay? I know it's kind of complicated, this whole idea. Kids usually struggle with this. Oh, look, I skipped this whole section here. Good thing I didn't turn the page yet. Fill in the blank with the numerator or denominator to make the number sentence true. So here, if I want to have something that's less than 7, this actually helps us with this. I want to have something that's less than 7, then I should have a proper fraction. So any number here less than 4. You could have a 1, you could have a 2, you could have a 3, any of those. 1 or 2 or 3. Okay, so let's just say 2. And then here, if I have 7 something times 15, and I want to have greater, I want this to be greater than 15, it has to be greater than 1. My scale factor has to be greater than 1. So in order to get a number greater than 1, I have to have something less than 7 here. So 1, 2, 3, 4, 5, 6 would work. Let's just put 2. So 2 and 2. And we can change them. I don't think that one has to be the same like the ones below. 3 times something equals 3. The only way you can get the same thing that you had before is by having this 5. Now, there are no options there. It has to be a 5 because 5/5 is equal to 1. The only way you can get 3 again is by multiplying by 1. Okay, 3 word problems, and you're doing great. Johnny says multiplication always makes numbers bigger. Remember what I said about always in yesterday's video? Watch out for that. Explain to Johnny why this isn't true. Give more than one example to help him understand. So You can start out with just, sorry, Johnny, but not correct today. Multiplication doesn't always, okay, that's the tricky word, make numbers bigger. Okay, it sometimes makes numbers bigger. If you multiply whole numbers, okay, so if you're coming from 4th grade, I have had students say, oh, well, multiplying always makes numbers bigger because 2 times 3 is 6, and that's bigger. 2 was small, and 3 was small, and 6 is bigger. And then I say, ooh, but we're going to multiply with fractions this year, and then I just prove everything wrong that they ever knew, and then it's very confusing. But so multiplication doesn't always make numbers bigger. If you take a fraction of a number, if you multiply by a fraction, okay, and let's just specify here, less than 1, like a regular fraction, you get a product less than what you started with. Okay, so if I take like 2/3 of 5, I'm taking 5, I'm putting it in 3 parts, and I only want 2 of them. I'm taking a fraction of this. Okay, so that is going to be less than 5. Okay, if I was to take, like, say 5/6 of 11, okay, and that means it's almost all of 11, but it's still not all of 11. It's break 11 into 6 parts and take 5 of them. Okay, if I had 1/8 of 2, it's still going to be less than 2. Okay, so I could put up a whole bunch more examples. It's just multiplying by a fraction. There used to be a problem on the test that was just like this, but I don't know, the test has changed a little bit. So maybe it'll be on your test, but study this one. A company uses a sketch to plan an advertisement on the side of a building. The lettering on the sketch is 3/4 inch tall. In the actual advertisement, the letters must be 34 times as tall. How tall will the letters be on the building? Now, this is a real question about scaling. If you ever are going to work in advertising, you're going to really have to know about this. Or in your home, maybe you do a garden model on a piece of grid paper, and then you actually have to plant it. So you have to scale things down and scale them up. Okay, so so how tall will the letters be on the building? So let's do 3/4 of 34. Okay, and so we'll have over 1. We'll just put in our multiplication. Well, we'll do 3 times 34 over 4. And when you see it this way, hopefully you're noticing that rule 2 of Mrs. Setness's rules for simplifying fractions. Always try to simplify before you multiply. Okay, 2 can go into 4 and 34. 4 doesn't go into 34, even though you look at it and you go, oh, look at that, might be a factor. It's not. 4 times 8 is 32, and that's only 2 away. So we're going to use 2. 4 divided by 2 is 2, and 34 divided by 2 is 17, an odd prime number. So 3 times 17 over 2, 7 times 3 is 21, carry the 2, 3 times 1 is 3, plus 2 is 5. 51 over 2. And when you get this, you're just going to simplify it. 2 goes into 5 2 times with 1 left over. Put that here and you get 11, and then you get 5 and a half. And so the letters will be 25 and a half inches tall. Okay, so we're taking the inch and then we're multiplying it because it's going to be 34 times as tall. So 34 times, not 1, Okay, it's a little bit less than 34 is our answer. So 25.5 is a little bit less than 34. If I broke 34 into 4 parts and I took 3 of them, which we've done with tape diagrams in the past, that would be about right for your answer. And 25.5 inches is also equal to 25.5 inches. So all that is equivalent. And finally, we have Jason is drawing the floor plan of his bedroom. He's drawing everything with dimensions that are 1/12 of the actual size. Oh, this one I think is, it took a little bit of doing. His bed measures 6 feet by 3 feet, and the room measures 14 feet by 16 feet. What are the dimensions of his bed and room in his drawing, which is only 1/12? So what you can do is you can do 1/12 of each of the measurements, and then you should have the measurements of his room. So let's do 1/12. And if you want to see what it looks like, so we've got the 14 feet by 16 feet. And then we've got the bed, and the bed is 6 by 3. So you can do like 6 by 3. So you can kind of see what it looks like in any fashion you wish. But it's going to be 1/12 of every dimension so that you can solve that. So 1/12 of, first let's just do the big one. 16 feet. And then that's going to be, of course, 16 over 12, which is going to be 1 4/12, which is equal to 1 1/3. Okay, and then let's do times the 14. 1/12 of 14 feet. Put that over 1, multiply, get 14/12. And then straighten that out and get 1 2/12, which simplifies to 1 1/6 feet. And the next one is 1/12 of the bed, which is going to be 6 feet over 1. So you get, now we have 6/12. So I don't have to straighten it out. It's a proper fraction, but I can simplify. And the final 1/12 of 3. So, yep, you have to do all this. Oops, I wrote it like that. And I have 3/12, which can be simplified to 1/4 feet. So, that's all you have to do. What are the dimensions of his bed and room in his drawing? So the bed is... Oops, sorry, that's the room. And this is the bed. Okay, 1/2 by 1/4. So that is how you do it. And somewhere over here I put to subscribe to the new channel, become a subscriber. Just had to do a little flippy floppy thing with my Laura Setness videos and turn them over to Mrs. Setness videos. So anyway, new channel, become a subscriber and you will get all the videos I upload, and you can be so smart like all my other students are watching these videos. So see you guys on the next one. Thanks for being subscribers. Bye.